Welcome! Today, we're looking at something that could totally change the game for doctors and AI. We're talking about transforming artificial intelligence from this kind of mysterious black box into a clinical partner that doctors can actually trust.
So just think about this for a second. What if you had an AI that didn't just spit out an answer, but actually walked your doctor through its thinking process, pointing out the evidence, summarizing what it found, just like a human expert would? Well, that's not some far-off dream. It's the exact question driving the incredible research we're getting into today. To really get why that vision is such a big deal, we first have to talk about a massive problem in medical AI, something everyone calls the black box. And the stakes here are, well, they're incredibly high. Chest x-rays are the go-to diagnostic tool pretty much everywhere on the planet. But here's the thing. Demand is way up, and there's a shortage of radiologists. That means doctors are under a ton of pressure. Fatigue, huge workloads, these things can lead to mistakes. So the need for a reliable assistant is more urgent than ever. And this is where we hit a wall. A standard AI might be super accurate, right? But it just gives you a prediction. It doesn't show its work. For a doctor, whose decisions can literally be life or death, an answer without a reason is a huge red flag. You just can't trust a number on a screen. You have to understand the why behind it. So researchers knew they had to find a way to crack this box open. And their first big idea wasn't to give the AI a voice, but to give it a way to show us what it was looking at. The technique is called GradCam, and it's actually pretty clever. It creates these heat maps that it lays right on top of the X-ray. These maps highlight the exact pixels the AI thought were most important for its diagnosis. It was really the first peek we got inside the machine's thought process. But this also showed a really crucial gap. I mean, seeing where the AI is looking is a great first step, for sure. But it's just not enough. It's kind of like someone pointing to a spot on a map without telling you what's there. Doctors don't just need a location. They need the story, the clinical reasoning, the why. And this is where things get really, really cool. This brings us to the real breakthrough. Instead of just trying to make the visual clue better, researchers decided to give the AI a voice by literally fusing two different kinds of intelligence together. So they took a convolutional neural network, a CNN, which is an absolute genius at analyzing images, and they paired it with a large language model, or LLM, which is brilliant at creating human-like text. They trained this new hybrid system on tens of thousands of X-rays that were already paired with reports written by human radiologists. So the AI basically learned to connect what it sees with how to talk about what it sees. And this creates this beautiful new workflow. First, the image expert, the CNN, analyzes the X-ray. Then, the heat map gives the doctor visual proof of where it looked. And finally, the language expert, the LLM, writes up a report explaining what it all means. So the doctor gets all three pieces, the image, the map, and the report. It's a full, explainable diagnosis, not just some random prediction. Okay, so the idea sounds great on paper, right? But does it actually work? Well, the researchers had to prove that this new AI colleague was actually better than the old black box. And wow, the numbers really speak for themselves. The F1 score, which is a key way to measure diagnostic accuracy, jumped from 0.80 for the old AI all the way up to 0.89 for the new one. That's a huge leap. It means the new system isn't just more explainable, it's flat out better at getting the diagnosis right, especially for those rare and tricky conditions. Let's make this real. This is what a doctor used to get. Cardiomegaly probability, 0.92. It's just a raw number. There's no context, it's sterile, and frankly, it's not very helpful when you're making a complex decision about someone's health. And now, look at this. This is the difference. Instead of just a number, the doctor gets a sentence they can actually use. It's a clear, clinical observation that sounds just like how another human radiologist would describe it. This, right here, is the jump from just data to actual actionable intelligence. Now, you'd think this whole sophisticated process would take a while, right? Nope. The entire thing, analyzing the image, making the heat map, and writing the full report, takes, on average, just 1.8 seconds. That speed makes it a totally practical tool for a busy, real-world hospital where every single second counts. So what does all this add up to? What's the bigger picture here? Well, it's pointing us toward a future where AI isn't just a tool, but a true collaborator in the clinic. But, of course, the work isn't done. The next steps are to make the AI even smarter, feeding it more context from a patient's health records.
Then they need to validate it with real radiologists in large-scale studies to really measure trust. And finally, they have to make absolutely sure the system is robust, fair, and safe before it's used on real patients.
And that brings us to this final, really powerful idea from the researchers. They describe their system not as a tool, but as a reliable colleague, one that doesn't just give you the answer, but shows you the proof and explains what it means. And that shift right there, from a mysterious black box to a transparent partner, might just be the key to unlocking AI's true potential in medicine.